Today we're going to talk about the theory that's behind what you're going to do there. So we'll consider the aggregation of individual firm supplies to industry supply by adding up the demands and the point at which firms are going to enter the industry. Because remember, we learned last class that firms might not enter until price is sufficiently high to overcome their fixed costs, right? And because firms will enter maybe at a discretely positive quantity when they do enter the industry, this can create some discontinuities or kinks in the aggregate supply curve. But uncertainty on the part of society about exactly when firms enter will help smooth out the average supply that will occur. We'll talk about free entry then, barriers to entry, and to what extent in the long run free entry occurs. So in the short term, firms can get rents from being more efficient than other firms. And in the textbook analysis, in the long run, that goes away because other firms are able to imitate them, enter the industry freely, and become as efficient as the best firms. Except in the cases when there are barriers to entry. And barriers to entry could either be good or bad for reasons that we'll talk about. Now, what I'm going to emphasize is that there are things other than just what we would usually call barriers to entry that might stop all the rents from being eroded in the long term. In particular, I'll emphasize the notion that different people have different talents and that it's not easily possible for me to just come in and imitate your talent. It's not easy for me to have free entry into being Steve Jobs or Bill Gates, right? And therefore, the distribution of talent across people is going to be very important. And we're going to try to quantify that with this idea of a power law distribution, and in particular, Zipf's law, which I'll show you does a very good job explaining the distribution of talent and size in many different contexts. And this will set the stage for many other things that we'll study throughout the course. OK. So deriving industry supply from individual firm supply is pretty simple. Basically, what you have to do is add up the supply curves horizontally. And this is particularly simple when all firms enter at a price of 0, because if all firms enter at a price of 0, it's just the inverse of the marginal cost curve that is the supply curve, right? And then if we take the inverse of the supply curve, we get back sort of the industry's marginal cost curve. OK, so let's consider a simple example of this. Let's imagine that there's an input that costs $1 per unit. And imagine there are 4 firms that have these production functions for that, based on that one input. Jacob R., can you tell me what the total cost functions for these firms are? Either just eyeball it, or if you want to come up to the board, you can do it. Well, so like, how about this one?
So if each input is $1, then you're asking for the total cost?
The total cost of producing output Q.
$1 times 9/5. It's $1.
So this says if I buy this many inputs, I get output Q, which is equal to this.
So it would be 9/5 to 5/9.
Times O to the or Q to the 9/5, right? Because Q is equal to this, right? Okay. So we then have to solve for I as a function of Q, right? So we get 5/9 to the 9/5 times Q to the 9/5. Yeah. OK, how about here? What would the total cost be?
It would be 3/5 over Q. I'm not sure.
It's going to be 5/3 to the 3rd power times Q to the 3rd power, right? Because you're trying to solve for how much your cost is, which is just because each input costs $1, It's just the input, right?
Okay.
So you've got to just take the inverse of this
Okay.
thing, right? How about here? Can you do that one?
Okay, so that would be 5/3 squared, because it's the 1/2, so that turns to 2.
Actually, I was leading you astray before. You only need to put the output to the power, because this is inside of the parentheses, right?
Okay.
So it's just output to the quantity to the 9/5 times 5/9, right?
Okay.
And so here, what would that be?
It would be 2 times 5/3. 2 times 1 to the 5/3.
No, it's going to be 5/3 quantity squared, right? Because equals quantity. So the quantity gets squared, and then you multiply it by 5/3, right? So let me do that on the board. We want to invert this thing, so we say quantity is equal to the square root of 3/5 I. That says that quantity squared is equal to 3/5 I, or 5/3 quantity squared is equal to I. And that's just the cost, because it's $1 per unit input. OK. Last chance, Jacob.
I'm dying.
How about here?
Okay, so we take I will be equal to 5 times q to the 7/5.
Woo! There we go. Very nice. OK. Now, Joe, what is the marginal cost corresponding to these total costs we just derived?
It'd be the derivative of each of those total cost functions.
Yeah?
Um,
Hit me with it.
so the first one would be q to the minus 1/4.
Yep. And the 9/5 that comes down cancels
That
with the
cancels.
5/9,
Yeah.
right?
And then the next
Wonder why that happened. Yeah.
Do you want me to do the rest?
Yeah, sure.
All right, so that's, and then the next one's 5q squared,
Yep.
and then you got 10/3 times q.
Yep.
And then 7q to the 2/5.
Exactly. Beautiful. OK. Jacob Conway, you want to give me supply functions corresponding to these guys?
Yeah, so you're going to have to take, since they're starting at 0, you're going to have to take the inverse of that. So it's going to be your p to the 5 fourths. And then,
Yeah.
The square root of p over 5.
Yep.
All,
That's right, yeah.
yeah. And then 3 times p.
Yep.
And then p over 7 to the 5/2.
Exactly. Beautiful. There we go. Now, to get the industry supply, we just sum these things up. And to graph things, because we usually like to graph with quantity on the x-axis, but you can have Mathematica flip the axes if you want. So that's what I did. So I had it add these things up and then flip the axes, right? And so that gives us these are each of the supply curves that you guys all just derived, and then we add them up to get the industry supply. Yeah?
So what are the axes for that?
Oh, sorry. Vertical axis is price. Horizontal axis is quantity. OK. So this was simple and nice because all the firms entered at quantity equal to 0. But when firms have fixed costs, they wouldn't enter there. They're going to require a higher price, right? OK. So let's go through and do another version of this where firms have fixed costs. So, or actually, I don't even think this is fixed cost. This is just a case where they just wouldn't enter at cost equal to 0 because their cost starts higher up. OK. So imagine that total costs were given by these equations, which we could have derived from a production function, but I'm not going to bother with that. K. Where's K? Who's K? I forget. K's not here? Oh, OK. Someone else want to derive the marginal cost from these total costs? Wesley, go ahead.
So the first one is going to be Q.
Yep.
Then 1 plus 1/3 Q.
Yep.
4 plus 10 at 5 Q.
Yep.
And then 7 plus 1/15 Q.
Yeah, exactly. Okay. So now Jackson?
Yeah.
Yeah, Jackson. Where are these firms going to enter? What's going to be the minimum price at which they're going to be willing to enter the market for each of these firms?
You know what, I have it in front of me here, but I don't, it's not clear to me how it's done. I'm sorry.
Okay, so these are their marginal costs, right?
Yeah.
Imagine that the price is 50 cents. Which of these firms would be willing to produce anything at a price of 50 cents?
The first one would be willing to do so.
How about the second one? Would he be willing to do it?
No.
No. Okay, so you're starting to get a feel for it. What price would these firms be willing to enter at?
The second one would be willing to enter at a price of 1.
Right? How about the second firm? Third firm, sorry? What price would he enter at?
I'm not sure.
Well, you got it here, right? You said that if it was below 1, right, then even at a quantity of 0, his marginal cost would still be 1. So he's not going to be willing to enter until the price hits 1, right?
Right.
So at what point will this guy be willing to enter?
When it hits 4?
Yeah, and at what price will this guy be willing to enter?
Oh, it's 7?
Yeah.
Okay.
See? So you just use the fact that they're not going to be willing to enter until the price gets up to the minimum level of their average marginal cost, right? Okay. So, and then what would their supply functions be? Jackson, can you figure that out? So we know that they're going to be 0 below the prices at which they're willing to enter. And then what do they become above that price?
Then they're going to be the inverse of the...
This is the marginal cost, so can you just go ahead and invert that?
Right, so it would be...
For the first guy, what is it?
would be 1 over Q.
For the first guy? P is equal to Q, right? So it's just P, right?
Okay.
So what about for the second guy? Just have to solve for Q. Set this equal to P and solve for Q.
Okay, so it's P minus 1. P minus 1 times 3.
Yeah, exactly.
Right.
And then how about here?
So then it would be P minus 4 over 5.
Exactly.
And then P minus 7 times 15.
Exactly. Good. See, you really can do it. You just have to not get too intimidated. Yeah, go ahead,
So
Jacob.
can we essentially think about it as just finding the inverse with the restriction that the supply has to be greater than 0? And if it's
Not exactly. If it's non-monotonic, then that's not quite true. I mean, we're not going to get into that, and I don't think you have to worry about that. But what you should think of is find the ironed marginal cost curve, and then take the inverse of that, basically. Okay, so these are the cost curves. Now, if we add these up, we get kinks. Why is that? Because these guys are not doing anything, and then we get to this point, and then they enter, and so the industry supply is a bunch of kinks at each of the entry points of these different firms. Okay. But if they enter at a positive quantity, this can cause real discontinuities. So imagine that firms' fixed costs are like this, and that their variable costs are like this. Then their